Hello friends, in this session we will discuss about how to implement binary trees in Inorder Traversal without using recursion. In Inorder Traversal, first we visit left node and then parent node and then right node. In our previous examples we have seen tree traversal by using recursion. That's one of the most common approach in tree traversals. Now here, instead using recursion, we will use stack and we perform Inorder Traversal. In our approach, first we will declare a temp node called current. In the very beginning, we'll assign the root node to current node. We are going to perform 3 steps iteratively in this approach. As a first step, given current node, which is root, we will traverse through all its left child nodes until it reaches null. So initially the current is pointing to root and then it moves to a node with 10 and then it moves to a node value with 5, and this traversal continues until it reaches null. During this process, every time current is pointing to the left child, we'll move this node to a stack before it is moving to next node. So this is our first step. The second step is, anytime current is pointing to null, we will pop out element from stack and print the value. That is second step. The third step is, once the value is printed, we will make sure that current will point to the right child of popped element. This is our third step. So this we will do in a loop until the current is going to point null reference and stack is empty. Now here is a stack and we have a current node reference, and initially it is pointing to root node. As a first step, we have to traverse through left children until it reaches null. So now initially it is 20. Before it is moving to its left child, push this to stack. So 20 is in stack. Now current is pointing a node with 10. Before it moves to its next children, left child, push it to stack. Now again we'll perform on this node. Before it moves to its left child, push it to stack, which is 5. So now the current node is pointing to null. As per our discussion, anytime current node reference is null, we need to pop out one element. So when we pop out, we will get node with value 5. Now print that value, which is 5, and the third step is assign the current value with its right child reference. So for this node, right is null. So now current node reference is null. So since it is null, again we need to pop out one more node from the stack. We'll pop out, which is 10, print the value and assign its right reference to current value, which is a node value 15. Now perform the same operation, traverse through its left children until it reaches null. So now as part of this, we'll move 15 to the stack and assign its left child, which is null. Since it reached null again, we'll pop out one more element, which is 15, print it, assign its right child to current node, which is null. Now again current node is pointing to null, pop out one more element, one more node from the stack, so which is 20. So print the value and assign current node reference with its right children, which is 30. For given node 20, its right child reference is 30. So now same process, traverse through its left children until it reaches null. So in this process we'll push 30 to the stack, then it points to 25, which is again will push to stack. Now current is pointing to null after pushing 25 to the stack. So now since current is pointing to null, pop out one element, print its value and assign its right node, right children to current value. So a node with value 25, its right child is null. So since the current is still pointing to null, pop out next element, which is 30, print its value and then assign its right child reference to current value. So C is pointing to a node with 35. Again same process, we need to traverse through its left node until it reaches null. As part of this, 35 also will be moved to stack and current is pointing to null. Now pop out the element and print its value, assign its rightmost child reference which is null, and again C is null. Now the current is pointing to null, stack also empty, we are done with traversal. Since we have taken binary search tree as an example, and when we perform Inorder Traversal on binary search tree, we will get output in ascending order, sorted order. So 5, 10, 15, 20, 25, 30, 35. So this is our approach. Now let's write code. Create a new class, tree Inorder Traversal. Create an inner class for node. I'll make it static. So this class has members like data, node references for left and right children. It has a constructor which will help to create an object for node. So this temp reference will be assigned to data variable. We'll have a member variable called root, which will keep track of tree root node, binary trees root node. Now let's create Inorder Traversal using stack. So it is of type void, it returns nothing. Do in order traversal, we're not going to pass any reference to it. Now if root double equal to null, we just return nothing. We don't have anything to print, that's why we just simply return it. We'll declare a stack of node type will import stack. So now we'll define a temporary node called current, and we'll in the beginning we'll assign root to it. We will use while loop to traverse through the tree. The condition, exit condition is this loop will run until either current node reference is not null or stack is not empty. So in this node, the current node is already pointing to root. As a first step, we need to traverse through left children until it reaches null. So we'll use a while loop again. The exit condition is current reference is not null. So in this, we'll push the current node to stack and we'll point current node to its left. So now once we are out of this while loop, the current is pointing to null. So now as a step number 2, we have to do pop operation. Take out one node from the stack and assign this to current. So now print this value, the node value. So space is a delimiter here. So we are going to print all node values in a single line, and space is a delimiter. So as a third step, assign current reference with its right children. Now this will continue until current is not null or stack is not empty. So now let's test this code. In order to save some time, I have copied main method code from my previous example and modified accordingly. Here I have created an object reference for tree Inorder Traversal and created a tree structure. Here I created a tree structure in binary search tree. So when we perform Inorder Traversal, we will get in ascending order. So now let's run this code and see the result. So now the data is printed. As expected, the data is supposed to be in ascending order: 5, 10, 15, 20, 25, 30, 35. So thanks for watching. Please subscribe to the channel.